Hi, everybody, and welcome. My name is Gwen Gringheis. I am the Assistant Registrar, Recruitment and International for the John H. Daniels Faculty of Architecture, Landscape, and Design. I'm so glad you're joining us today, and I assume you're here to learn a little bit more about the PhD program. And we are joined by Professor Claire Zimmerman, who will be able to lead us through a presentation on the program. After the presentation, we will be able to open it up for questions. And so if you do have any questions during the presentation, please use the Q&A button at the bottom of your screen and input your questions there. After the presentation, we will be able to answer all of those questions. Okay, so we will go ahead and get started.
Hi, everybody. Lovely to see you. I am here, and so is my colleague, Professor Maria Jablonina. She will speak to the slides in her area, and I will speak to the rest. We're very happy to see you today. If I had to describe our PhD program generally, I'd say we are a multimodal, multidisciplinary advanced research program in areas related to and adjacent to the built environment in all its iterations or all its manifestations. That's at least our claim. Here are the main subject areas that we cover to date: history and theory of architecture in built environments, landscape studies, visual studies, art practice and research in the arts, urbanism and urban history, infrastructure and globalization insofar as it affects the built environment, environmental science, computation and robotic fabrication, building science, and adjacent to us is a PhD program in forestry. It's a new relationship, and we're slowly building up more robust ties with our forestry colleagues as well. So there's a very wide array of subjects that you can tackle in subjects related to the built environment here at Daniels. And of course, we are in the middle of a very large university that supplements everything that our students try to do with related departments and units that are really helpful for educating them. If you go to this link, you're going to get a list of names like this. And I want to try to keep the focus a little bit on what our current students are doing right now, because I think that's probably a good way to give you a sort of cross-section of our program. I am also going to talk about faculty profiles in some of our areas, and I'm going to let Maria tackle the first topic. We're going to cover these three today: history and theory of architecture and built environments, environmental science, and computation and robotic fabrication. And we're going to go in reverse order. So, Maria, the slides are up for you next. And then I'll say whatever I can, unless Maria wants to, about environmental science. And then we can talk a little bit about things that are ongoing in history and theory.
Thank you. Thank you, everyone. It's lovely to, I guess, not really meet you, but at least have this opportunity to speak at you. My name is Maria. I'm an assistant professor at Daniels since January 2020, and I specialize in robotic fabrication, specifically focusing on mobile robotics. And together with Brady Peters, I guess we are the two professors at the Daniels faculty who supervise PhDs in these areas. That is not to say that we're the only people who actually do the work in these areas. We are very lucky to be supported by colleagues at the university, both on the faculty side and the staff side. But yeah, within our robotic fabrication and computation focus, we do quite a bit of work with industrial robots, like the one you see on the slide right now. So we work with industrial robotics, trying to figure out new ways and approaches to materials to sort of sorry, my phone's exploding for some reason. There we go. To explore new ways of approaching materials through robotics. So we're explicitly not interested in labor automation, but rather thinking through the ways in which precision and control that robotics affords in combination with certain things that robots cannot do. For instance, they're not really good at being intuitive, they're not very good at sensing. So, how can we combine these tools with human-centric intuition, human-centric material studies, and human-centric understanding of materials in order to explore new ways in which we can build, new ways in which we can fabricate, and new architectural spaces or aesthetics or applications that we could achieve? And I guess in terms of what the work that is currently ongoing within the PhD program, we have PhD students exploring fabrication methods with new materials, as well as PhD students who are working with new types of robots, so rather developing their own machines and looking into applications of theoretical concepts such as queer theory to sort of rethink and re-understand the academic context of robotic fabrication in architecture and in general. I hope that covers. Oh, that's great. I wasn't sure if that slide was in.
I was waiting for you to advance the slide, Maria, but of course I have to do it.
Oh, I
I have
see.
a series of slides for you here. Yeah.
Oh, that's awesome.
Wanted to emphasize the collaboration between you and Brian.
Yeah, that's perfect because I also wanted to mention that. So yeah, this the slide that you see on the screen right now is a screenshot of the paper that was written by my PhD student, Brian Slocum, who is co-supervised by myself, my colleague Mitchell Akiyama here at Daniel's faculty, who is on the visual studies side of our faculty, and Jasmine Rout, who is from School of Information. So I guess Brian's thesis and his ongoing work is actually a really good example of one of the more, maybe one of my favorite aspects of our PhD program, that it's not only positioned inside a very interdisciplinary faculty, but we also have all of these tentacles spreading out towards the larger community at U of T. So we're always striving to create this, I don't know if dream team is a good term, but maybe for each student that combines experts from our faculty, and if we don't have the experts, then experts from other faculties to create this, interdisciplinary environment for our students. I don't know if there's another slide.
There's some more. This is
Okay,
more
great.
about your work. Maybe you could speak to, um,
Sure.
whoops, these guys.
hmm yeah, that I guess just some of the examples of my ongoing research that I will actually explicitly be looking for PhD students to support. So although I teach across the space of industrial robotics and other kinds of machines and applications, my own research focuses on mobile robotics, so machines that are built in-house, developed, designed, programmed, pretty much everything. And we're currently focusing on new applications for sensing equipment for existing buildings, specifically focusing on renovation. So this example that you see on the slide is a custom steel pipe climbing robot that allows to scan existing steel pipe structures. It was actually built for a very specific renovation project for the SOM Cadet Chapel. But the purpose of this machine is to scan an existing structure and assist in renovation markup and layout. So again, not necessarily automating existing tasks, but making some of the manual tasks that are extremely difficult in terms of measurement more possible, and then assisting with an installation where the machine works in cooperation with a human worker. And I guess that's concludes um, the overall presentation in terms of the robotics side. The image that you see on the slide right now is some of the earlier work in also mobile robotics for in situ fabrication and production.
Um, I wanted to note, Maria, that the work that you've done with Brian and Mono is just really fascinating in the sense that both of them, while they work directly with robotics and they're interested in robotics as the center of their projects, they're also both extremely sophisticated thinkers and are working at a high level in specifically in my area, for example, in Brian's case in the area of theory, and in my case in history, in Mono's case, more in history and theory, I guess you could say. So that's been, I credit you and Brady with that kind of the fertility of your area is really striking at Daniels. And I think students who are considering our programs should know that we have, I think, really a quite unusual computation program, largely because of the robotics side of it. So I think that's the end of the slides. Let's see. Um, did you want to say anything about this one?
That is an example of Brady's earlier work. I guess
Okay.
talking back to what I was saying that we're not really interested in automation, but in exploring how precision allows for new interaction with materials. This project was an acoustic wall made of these identical wooden bricks, but the robot positions each brick at a unique angle and a unique place, which creates this reflective wall that is, I'm not quite sure if I have the expertise to talk in detail about how it reflects the acoustics, but it creates this really specific effect when exposed to sound. And that is not something that would be easy to do or possible without both the computational tool and the robotic accuracy. But then again, it sort of folds the human back into the loop instead of just removing them entirely.
Great. Thanks so much. So I think you and I together, Maria, have to try to present Alston's work. He was unavailable today. He'll be here at the next open house. But Alston Jakubiak is really the sole faculty member who works in environmental science at Daniels, although he has backup in Professor Ted Kessick and Professor Daniel Chung and Professor Bomani Kemet. So they have a good, healthy group in building science. Alston's work and the work of his students, which you see here, is really, there has a lot to do with sensing and measuring, sort of quantifying qualitative aspects of architecture and the built environment, and then acting back on them. So first you measure, then you figure out how to correct, let's say, or improve or ameliorate or optimize. All of those words, I think, come up. What do you think, Maria? Is there more to say about this that you could do better than me?
I think that is a very accurate description. Maybe I'll say a few words that he's working a lot with hospitals and like environments where the quality of the built environment is not only important but really critical. So both in healthcare, where the amount of daylight and air circulation become arguably more important than in other contexts, as well as some of his more recent work in social housing projects, from as far as I understand.
Oh, yeah, that sounds right to me. And just looking at this group of students that he's working with now, actually, Shoaib is working with Daniel Chung, Fionn is working with Alston, and Nazanin is working with Alston. Here are some of the kinds of projects that our building science students are working on. Daniel Chung is very, very concerned with energy retrofits and with housing. He does a lot of work for the CMHC, which is a federal funding agency here for housing initiatives. So you see a little bit of the kind of projects that his students are working on as well. And then finally, I can talk a little bit about what the history theory area is doing. I'm gonna do this because there are quite a few faculty in this area. You have more students have more to choose from if they're trying to do a history theory degree. So I thought it would be helpful to highlight the work of some of our young faculty members in this area. Not everybody, but my colleague Jason Nguyen is the only early modernist that we have, and he's just finished a book about expertise and early modern architecture, so the development of the architectural profession. and he's moving on to work on questions of trade and infrastructure, both in North America and in European contexts, and in further colonial contexts further afield. He's interested in trade, he's interested in infrastructure, he's interested in material histories. Um, and he has taken on his first PhD student last year, so he will now be supervising more regularly now that he has reached and hopefully passed the promotion gate. My colleague Peter Seeley is a modern architectural historian. He works in photography, film, media studies, and Canadian history. He recently published a piece about film and the Berlin Wall in film, which you see here, published in eFlux. That's Checkpoint Charlie. And Alexander Bierig, our newest hire, is working on histories of energy, infrastructure, and empire. And he's been recently featured at this event on building, land, and coal. And he is teaching a PhD seminar on what he calls fossil space in winter 2026. So those are some of the profiles of our history faculty, history and theory faculty. I'm not covering everybody here. This is more like a kind of a sampling of what our faculty do. I would advise you, if you're interested in our program, make contact with the faculty member with whom you think you might like to work. You are not absolutely committed when you walk in the door, but you do need faculty members, more than one ideally, to advocate for your application. So you need to have some back and forth with those faculty members if you can, and present your credentials to them and make clear why it is important for you to work with that particular faculty member. And you can find all of those colleagues listed at the end of this presentation. I want to move now just to talk a little bit about our physical plant. There's our building. This is a pre-renovation slide, I think, or renovation is kind of underway when they took this image. It looks much greener today. But it is this building standing on an island in the middle of Spadina Avenue, right in the center of Toronto, a very urban location, wonderful part of the city to be in, right adjacent to the University of Toronto, but really on its edge. This is the space in which our PhD students have their desks now. It doesn't look like this anymore. Each student has their own workspace in there, and it's really a kind of a wonderful spot where there's a work table where we can kind of gather and have meetings, but every student has their own space with shelving and so forth. The new building shows on the right of this image, the old building on the left. I'm not going to talk about the new building. It's by Nader Tehrani, and it's a wonderful place. You can look on our website, and you'll find lots of information about the juxtaposition of old and new in the building. There from the other side of Spadina, and the image that we began with, you can see the landscaping now in that image. The core faculty are listed at this link. Please spend time on that link, finding out what we do. PhD study is extremely customized. You really come to work with a group of people, and we can't support students who don't work in areas in which we have expertise. It just makes sense. We would be irresponsible to accept you if we could not help you get where you're trying to go in your research plans. So be careful to find a match with members of our faculty. When there's a good match, you will hear back from faculty members. They'll be excited to talk to you and to read your material. If you don't hear back from someone, chances are it means that the match is not all that great, or that they are unable to take on a new student at this time. I think that, Gwen, I think that concludes what I had to say. There's the current student list again. And we could start to take some questions. Do you want me to
Absolutely.
leave the slide array up or take it down
You
or?
can stop sharing your screen and we will open it up for Q&A.
Okay.
And I will just pause the